my idea is I'm gonna kind of talk you through an approach to resynthesis that I've been doing for the last 6-7 years, and an older version of it, and then I guess where it currently is at. So the start of this, let me let it open. A little bit before I started my PhD here, I started working on, I got inspired by some stuff that PA was doing with audio input based resynthesis. Actually, I'll just play a little example of that, of my implementation of it. So this was kind of an early implementation of it, and that was basically stuff I rolled more or less from scratch into, at the time, the tools. If you wanted to do this kind of, you had Hart, and there was a few more, but they were a big pain in the ass. They were huge, clunky. They had really big dependencies and very fickle dependencies. So you had to have a certain install of Max, a certain install of FDM, and if any part of that is changed, you risk doing the whole thing. And it was like an unintelligible mess of a patch. So I had no interest in getting into that, and a lot of the software I make I share freely, and I didn't want to encumber other people with that sort of thing. So I built a version of this, and I kind of tried to strip it down to make it as easy to use as possible. And I did, I shared it, and I'm very happy with it. I still more or less use a version of that. Then years later, I wanted to rebuild something like that, knowing what I know now. So, I mean, I've got some of the sort of things that I may or may not talk about that are here, but I'll basically show you where that idea is now. So, if I take this here, and I play a little Shania. I'm so glad we made it. Yeah. Oh, it's on. The resolution looks weird because it's scaled up. So that's just playing.
Okay, good, sorry.
So I've got a corpus of accordion sounds, noises recorded from an accordion. So glad we made it. Look how far we've come, my Okay, so that's an accordion. All electric guitar. So. Yeah, that sounds all right.
How big is your?
It varies. So that accordion one is fairly small. So that one is 28 megabytes. I've got some that are quite a bit bigger, but so to kind of sum up some of the bits. So I'm doing other descriptor stuff for loudness, pitch, spectral centroid, and noise, which is spectral flatness. Okay. So those are the 4 descriptors that I'm doing. And to kind of, I guess, rewind a bit more, I'm creating, there's a process where I create the corpora that generates 2 files. So one is a JSON file that has all the, sort of the name of the thing. This one's a porn one, which I'll play you a bit of. Descriptions of it, and then some metadata like the length, file size, and all this. The analysis settings I used, so I can kind of recall that, and I can bring back and match according to those descriptors. And then some min, mean, and max values, which I'll use for normalization, which I'll talk to in a bit, and some histogram stuff just for UI things. And then there's a text file, which is the analysis data itself, which is, you know, in this particular one, the porn one is, I believe, like 40 minutes. It's my longest one. 36 minutes. So that one's a pretty substantial one. So the general idea, I wanted to be able to do stuff like this and use it in real time with instrument input. So this, more or less, I just made what I had before, but better. And that worked well. And there was a couple things that I wanted to be able to do. One was to be able to use more than one corpus at a time. So here I'm using the accordion. I'll play so there's kind of brushes. So there's my accordion one or my electric guitar one. Or if I want to do like some circuit bent things. So now if I wanted to do all of them. So the color down here represents which one is matching from. So I'll go back to CeReNeM, maybe that'll be better. So that's the circuit bent. I don't have a lot of pitch data in there. But now if I match all of them. So it's picking the nearest one from each one of them. Now, one thing that I missed in doing this, so that's more or less as straight a resynthesis as I can do. I'm querying for specific, okay, like my input grain is, it's this loudness, it's this pitch, it's this center, this noise. Find me the nearest one from the database and play that back. The match doesn't exist. So, you know, within a window of threshold of what you can find. So one way there's three things in here that I guess would be interesting to talk about. One is how I deal with normalization, one is correction, and one is how I do pitch pre-compensation analysis. So to show this an example, so CeReNeM again, you can hear that as she sings a melody, there's gaps in the data where some of those notes in her little...
Sorry, can I just ask you, I know it's a stupid question, what do you mean by pitch? Is it an F0, is it a main pitch?
I mean, I mentioned like the pitch descriptor in Alex's descriptors thing, so it's like
okay, I'm sorry,
F0.
Is it F0? Okay.
Yeah.
Because in your example, you have a polyphonic sound where bass kicks in. Does it take the voice as pitch?
No, I mean, I think it takes the...
It's whatever is the loudest. It's the biggest one. It's a kind of a Sigmund...
Is it really the loudest partial taken? Okay.
It's the basic fiddle algorithm that's been put in the...
Yeah, it's not
the most intelligent thing.
So this is a spawn of question. Does anyone know what the main pitch
tracker?
Exactly. No, not the loudest. Not
in my experience, if you use a monophonic pitch tracker, not the one that picks the largest of the one of these actually.
It's a discussion you can have over coffee. That's a discussion. Let's do that.
Just quickly.
It
It was a bad question.
It's okay. No, it's a good question. Just need to link with it.
So when you're in your analysis, is your pitch over time, or is it just
per grain? So I think this is like every 40 milliseconds. I'm sorry, every 10 milliseconds, I'm analyzing 40 millisecond windows, and then I do a little FFT on that 40 milliseconds, and I get the loudness, the pitch of that 40 millisecond.
in your corporate?
Yeah.
Yeah, okay. And then it goes to that specific grain.
Yeah.
When it plays.
But now, so there's a couple things. So I'll just go back to the accordion one. So you can hear it's kind of quantized to the database. Okay, so I have a thing that I can compensate for pitch or loudness. I'll just kind of crank them both up, and it's some. So there's still gaps. So what it's doing, it's returning the nearest whatever of a threshold that I can give it, and then whatever the difference between. So like this is a grain I want, this is a grain I found. The difference is this much, so transpose it by this much. And then it plays it at the...
So it's a post hoc operation to correct for that.
And same thing for loudness.
Do grains overlap or
Yes.
On the playback, so I've got two modes of playback. So this is sort of straight read. This I think it's doing every 10 milliseconds. So it's just straight grains. But one of the things I found with this, I missed in the video I showed before. My analysis was periodic, but my playback was aperiodic and random windows. So there was a lot of informational noise in it. So it wasn't accurate, and that was a feature. So here, this is accurate, as in like the grains are the same size that I'm playing back, and they're playing back at the same rate roughly that they were analyzed. So I wanted to be able to, I go into chunky mode, which is this other one. The analysis data is static, so that stays the same, but now I'm playing back aperiodically and at variant window sizes. Meaning, so if I play a grain that's 80 milliseconds, the 40 milliseconds have the correct pitch. The other 40 milliseconds are, I don't know. But then you start getting stuff that sounds more like this. I'll turn off the compensation. So there's a bit of the gist of the thing really interesting if I turn on, so this is all the little corpora. And I've got different like window, like I'll change to like a kind of more with different window shapes. Actually, this one's for you, Pierre. I didn't show this in the last one. So I'm gonna load along this. So this is actually one of my favorite.
Oh god.
Yeah.
Yeah, I've seen that.
So I'm gonna load the porn one. So the porn corpus on its own. So it's. I'll go back to the basic setting. So it sounds kind of like regular resynthesis. There's not a lot of pitch in porn, as it turns out. All right, so that's that, but it gets really interesting. So if I go into this chunky mode, slow rate, kind of big size with an onset window, and I mix between all the corpora. Yeah, we'll play some drums. I'm not getting too. Oh, there you go. There we go. So you kind of like an interesting mix of Oswald-esque source overload, because the grains are coming you at a rate that's faster than you can really process, and that's literally I'm feeding that this, you know, and yeah. So obviously the corpus itself has a big impact on and in this case the curation of specific corpora. So I've got in this case 4 corpora loaded. So I can load specific ones if I want to get different sounds. So the correction was one thing I wanted to talk about in that querying specifically, and this was kind of when I asked you, Hans, if you were transposing the pitch or the query. Like this was one way where, okay, I've got what I want, but this is your solution where I transpose the thing. So another one here, so let's say I don't have any corpora that are like this, but let's say I have a corpora of flutes and I'm playing in double bass. So frequency is not gonna, like pitch and for the most part centroid are not gonna overlap very much at all. So if I just send that straight in, it doesn't match very well. So I've got a toy piano one here that let me clear all. Okay, so here's a toy piano one. I'll play Shania. Okay, so there's like, you know, almost not, I mean, I'm not going, I can control the weights of the different parameters, and I did a kind of cool thing where the order, the one that are ranked higher gets sorted first. So here, my loudness is the one, so if I turn that down, it'll look for pitch first, etc. So I've done a kind of cool thing there, but you can hear there's not much happening. Okay, so the reason why when I pre-analyze the corpora, I get the min, mean, and max is because now I know roughly, it's not perfect, but the min, mean, and max of this corpora. So my data set is this big. My input is unknown at the moment, but I can train it. So I have a few presets that I can select from, or I can learn input. So I'll just feed it some Shania Twain for a bit, and then learn input. And then that takes the last 4 or 5 seconds and does a min, mean, max analysis on that. So now if I normalize that, I have not tried it with this preset, but it's not a big deal. Let me try accordion. Actually, a good example is accordion with drums. And I'll go back. Okay, so that's my accordion and drums. There's not all lows there. So I'll learn input. That sounds terrible.
You're not playing the right one. I thought you were learning the input of the drums.
at minimum you can hear that there's more lows and highs present.
Yes.
I mean, I could go in here and fine tune the matching parameters and all that kind of stuff to get a more responsive thing, but there's parts of the database that are now have access to me. And all it does, it takes whatever your input database is and matches it to your output database, however they may be shaped, in the min and the max, but also the mean. Because if I just take the min and the max, you have kind of outliers. And it'd be cool to get more sophisticated in that, but this is just sort of a general approach to kind of correct for that. And then the third one I do here is I wanted to have, actually should not have worked fine. This pitch correction. So what this does, I'll show you this analysis I did here. I had my corpora and I analyzed it and I played it back, and then I started experimenting with transposed version of the corpora. So I did transpose the corpora at half speed, then analyze that and match against it, and I was like, oh man, that sounds fucking great. And I did quarter speed and double speed and all that, and I was like, it'd be great to be able to use this, but it's impossible to create a database that contains every transposition of a possible data set, because it would be enormous. And sure, I could do these octave divisions of it and then have a data set that contains all the transpositions. But what I did instead is I analyzed them and then I looked at how the data moves. So pitch moves roughly as one would expect. It moves in octaves. Loudness, perhaps not unsurprisingly, moves a little bit. Centroid moves, but not at the same scale as pitch moved. And spectral flatness moved a bit as well. So what I did is and I took a couple more data points in this, but I just came up with a formula for each. So rather than having to have pre-analyzed the corpora at different transpositions, I can feed it the same data, and then when I query a compensated number based on the expected transposition. So if I want to, I've got Shania again. Now I'm not transposing the playback, I'm transposing my query.
Does this not hugely depend on the type of sound you get
totally.
as input?
Yeah.
I mean, this will work with the accordion sound, but will not work, for instance, with a subtractive synthesis sound.
Yeah. It's
the centroid will move differently, and
That's the good thing with this. Just for the nice thing is the corpus is the same as the target. So you have a big corpus and you use the target is the same, but we change the parameters like the pitch and you get super interesting things because it's very close, but it doesn't find it's not recreating, it's not a pure resynthesis, it's a resynthesis of the same thing but on another level. With another parameter.
Which sounds good. So if I loaded my guitar one, which has a bit more note data, so the non-transposed query. So these are untransposed sounds, but matching. So there's less, at the extremes you have less matching. But as opposed to transposing what you want, you search for what you would have wanted had it been transposed. And then you can do both. So I can do that and then compensate. I'm going to do nothing of it.
What is your middle correction doing exactly?
The what?
The correction. What is it actually doing? I mean, on the values.
It's so if I want pitch 200 hertz, it finds me 190 hertz. I do the math transpose it by the transposition factor.
And what's interesting is the value. One is 100%.
And then
to 50.
And then there's it's clipped at a certain thing because if it hears 0 hertz, it won't transpose. So I've limited it to a range. The volume correction I'll allow a bigger correction, but the pitch correction I'll allow a smaller correction because it will hear this with all these weird and it's like, oh, that was 2,000,000% higher than what you just played. So I will, transposing up is fine because it goes really short, but like if you go down 2,000,000%.
What's the percentage?
Which one?
Pitch correction 100%, I presume.
Yeah.
So what's 50% pitch correction?
Oh, it's whatever the number, whatever secret number, not secret, but like 5%, whatever number I pick to be the maximum correction, it's half. So it's a linear thing with
Okay, so you can almost correct. So you get 90 instead of 100.
Yeah, like even at 100, it's still clipped to a range.
Yeah.
I mean, like
But 90 would be almost reaching for the pitch.
Yeah.
Okay.
Like it transposed it mostly there.
Okay.
Yeah.
You use weights for loudness, pitch, sound,
Yeah.
and noise.
Yeah.
Do you do Malahanumis or what kind of?
It's the entry matchers nearest. So like
Okay.
plus minus 3 dB.
Just the geometric.
Yeah.
sounds.
But as I said, so I can they're queried in the order of how they're ranked. So
Okay.
if I'm not interested in, so I'll turn this back to normal.
So there is a order in the weights.
Yeah, there's an order to them. But if I don't care about loudness or centroid, or I don't care about pitch, loudness I care about.
Nice.
So you can get some kind of interesting things like. And I'll kind of I'll show the patch itself because that's the part of this is I'm doing it as a max for live devices, as you can kind of see.
I was going to ask, is this max for a live device?
This is a max for live. I've just loaded it to max because it's easier for me to use negotiate.
So
Yeah.
we can download it.
Yeah.
Oh, that's good.
Great.
Yeah. All
So the max for a live library download.
yeah, I'm almost done. Like there's I'll put the link on the forum, like on the discourse forum.
That'd be killer.
Yeah, like I've been talking to Ableton for because in order the corpora can get kind of big. So the max for live device itself is about 400 megabytes because it has a few built in, but I had a lot more. So I wanted to be able to do it as like an expansion pack, so you can add them. Either way, it'll be free. I want to put it up to them, but just free. But I'll put the link for it. But I'll show you the guts of the actual patch.
How would you build your own corpus?
No, go on.
How would you build your own corpus? I mean, you just
Exactly.
write. And that's the same as my question.
I'll show you. Yeah. So I've got a separate.
Okay, it's a separate
It's
patch.
JSON files, no?
Yeah. So I'll show you.
It's a patch. Okay.
Which I spent some time to make it kind of slick as well here. So here's I'll analyze the file. So
Okay.
drag file here to analyze. It asks you for some metadata. You can put in or not. And then I did a thing where, as opposed to pinwooting, which is what you were getting, Hans, when you're querying, I manually iterate with defer load. So my computer's free to do stuff. Because if you load a really big corpora, like if I'm analyzing the porn corpora, you walk away for like 15 minutes. Like it's gonna take its time. This is a 28 megabyte file, and then
It's doing it online or offline?
it's doing it as fast as possible,
Okay.
but not oozy.
Is it patching or is it?
It's
code?
the object, I think. No?
I mean, is there some descriptor?
Yeah. So it's doing
Okay,
descriptors,
so
but
it's
it's doing not real time. So I'm search for here to here for these descriptors. Once it's returned that, now go back, search from here to here, and then it means like the timeline happening at the top is that process. And then you can also see the descriptors that it's finding populate in real time. And then I did a bunch of to try to have the interface unified, like loudness is represented as that color everywhere in the interface and all that. And then when this is done, it'll be done shortly, it spits out a JSON file and a text file. And then when you go to load a corpus, it will only read a JSON file.
But if we go back to your previous version, the standalone version that people can download, both tools still exist.
Yeah, so there's a device that's the create corpus one, and then there's the device that's the player. And then the patch itself, which is quite closed. I'll open the main patch because it's very messy.
It's a good sign.
No, it's very tight. This is only my demo version, like when I have that.
No CD of Max.
Super
5
tight.
minutes.
Yeah.
For me,
Yeah,
it's
it's
super
crazy.
easy. Huh?
It's crazy tight.
No, wait, it's not funny.
Yeah, it's
It's like,
I mean,
he's putting us all to shame. I've never seen it. I was working with him on many things, and you give him a patch that you've done this, he's happy, like my type detector. The next day I arrive, it's all commented, it's made like, for fuck's sake, what have you done?
yeah, I mean, part of it is a little OCD-ness. A bit of it is also like code self-management. Like in 2 years, I'll come back to like, what the fuck does this do? So it helps me for that. But also the fact that I share share the patches of Max Live Device, but also the patches there. So if someone wants to open it and learn, they can.
Are you seeing a psychologist?
No.
4 minutes.
So you see, you rely on send or receive to do things.
Well,
Which means that I cannot have two instances of the same.
No,
you can.
You can with that.
Okay.
So in Max for Live, it's like using hashtag 0.
Hashtag 0 for
Yeah.
Max for Live.
Exactly.
Yeah, so you can have multiple instances of it and they're fine.
Okay.
And at minimum, like there's not a lot of, I don't use sends too much. I also did a lot with dicks. This was the first patch that I did a bunch of stuff with dicks, and they're a pain in the ass, and no, they're not, but like the documentation is terrible.
Yeah, that's right. But
Yeah.
actually, once you've got your head around it, it's really powerful.
I think there's an interesting thing. Alex has sent bogged them a bunch because of the way. So, for example, my big database, if I load into a dict, it takes like minutes to load where your pinwheel. It doesn't handle big data well, and it's because of how they've done something stupid. And he's bogged them, and apparently, I guess they're now addressing it.
Sure.
I mean,
But it
like
makes
Pete said
sense.
that like they fixed it.
Is it to do with the bins in the thing?
No, it's
There's only
like.
like 75 bins.
To do with the fact they reparse everything every time you add a line or something.
But it's something that has to do, like if you have, because my library it's a lot of top level data. So like entry 1, 2, 3, 4, 5.
Yeah.
If you have entry 1 and then entry 1 has 10,000, then it's still slow, but it's way faster. It's the fact that if you create a million entries, it jumps.
We're talking about a million entries in this database.
Yeah.
That's why the querying is not fast enough.
Yeah.
So what are you doing then?
SQL.
You're not using.
I'm using entry metric, which is Alex's database lookup object.
Which is what I was telling you about yesterday.
So it's this one here, and he's made his later version of it. You can actually click and see and like, and it loads like the previous version of this patch. If I went to load like any of the corporeal, it would take a second. It would like pinwheel, and it was usable, but it was fine. If I loaded the porn one, for example, which is my biggest one, you click it, 3 or 4 seconds later, it would load 100 milliseconds. Like, no, I'm sorry, like 14 milliseconds or something like that. Like the loading time, he optimized to be insane. Even to the point, like when I clear all my databases, I'm actually doing that dynamically. Like let's say I have 5 loaded, and I want to clear 1, I'm literally clearing all of them and loading 4 again in the time that like you just click the menu item. Because of how my offsets are using for the database.
It's been optimized for real-time query.
Yeah, like super
it's
fast.
amazing for that. There's other things it doesn't do well. You can ask Alex, he will tell you. You have time for 20 seconds or something.
Yeah, any other questions? Yeah, I'll put the link on the webpage.
Great.